As I told you some moments ago, there are many properties which guarantee uniqueness of equilibrium, or some weaker property. We have no time to explore all these arguments. I limit myself only to another important result. Under what conditions the set of equilibrium price system is convex? This is clearly a weaker property than uniqueness. To illustrate it, let us return for a moment to our pure exchange economy. This is the point which represents initial endowments. Repeat the same case of before. This is an equilibrium, say point alpha, allocation alpha. This is another equilibrium, say allocation beta. In this case, clearly, equilibrium is not unique. But it is possible that some particular condition, some particular hypothesis, every price system intermediate between P prime and P double prime is another equilibrium price system. So take P prime, P double prime in delta, take any lambda in the unit interval 0, 1, the price system P defined as P lambda times P prime plus 1 minus lambda times P double prime is obviously another element of delta. Under what conditions, if both P prime and P double prime are equilibrium price systems, also this intermediate P is an equilibrium price system. This means that you pass from these two initial price systems to this intermediate price system. You have also, in this case, equilibrium, say, allocation gamma. And so on for every intermediate price system, for every budget line comprised from initial and final ones, is another determinant, another equilibrium price system. In order to have this result, which is clearly weaker than uniqueness, you must introduce another property which is typical of consumption theory, the well-known weak action of reveal preference. This acronym WARP, you remember, weak action of reveal preference. Weak action was defined while speaking of individual behavior. You remember, when in the first situation a bundle X is demanded while a bundle Y is only purchasable, then in any other situation according to which Y is demanded, X must be non-purchasable. This is a well-known weak action or reveal preference. The assumption is the following. The same assumption holds for the excess demand correspondence. So let us restate this weak action with reference to the correspondence large Z. If in a certain situation P prime, Z prime is an excess amount vector corresponding to this price system, and the value of another vector Z double prime is less or equal to 0. In other terms, this second vector Z double prime is purchasable in this situation, then if Z double prime is an excess demand vector with another price system, sorry, and there is another assumption, and that second does not belong. It is only purchasable, but is not demanded, so to speak. Then, in any other situation in which Z second is demanded, so to speak, then Z prime is not purchasable in the second situation. This is the weak action or real preference referred to the excess demand correspondence. But clearly, the statement is the same that in consumption theory. I repeat, in the first situation, Z prime, so to speak, is chosen, where the price system is P prime, while the vector Z double prime is purchasable. Its value is lesser than 0, but is not chosen in this first situation. Then, if in another situation Z double prime is chosen, the original Z prime cannot be purchasable. Its value is a positive number, so it is not possible to purchase it by the whole economy, so to speak. Is it clear? But obviously, this is nothing but the usual warp, referring not to the demand correspondent D of a single household, but to the entire economy, households and firms together. Remember by Pacini, even if every demand correspondence verify the weak action real preference, generally speaking, this does not imply that the excess demand correspondence satisfies the same property. In other terms, warp does not resist under aggregation. When you aggregate the different individual behaviors, you are not sure that the aggregate behavior verifies the same property, even if each individual verifies it. This is true only under some very particular assumptions, homogeneity and quality of preferences and so on. But generally speaking, the warp at the individual level does not imply the aggregate form of a weak action. This property. Or, if by chance the correspondence Z verifies this property, it is easy to show that the set of equilibrium price systems must be a convex set. Let us prove this result. If Z verifies war, and for every P in, say, delta, Z of P is non-empty, then the equilibrium the set of equilibrium price system is convex. This is our theory. If the excess demand correspondence verifies the weak action and it has not empty values, then the set of equilibrium price system, which possibly could be empty, however, it is a convex set. The proof, as usual, is ab absurd. Let us suppose that there exists two different equilibrium price systems. P prime and P double prime. And suppose that there exists a lambda in 0, 1 such that lambda times P prime plus 1 minus lambda times P double prime is not an equilibrium price system. I repeat, both P prime and P double prime are equilibrium price systems. But there is an intermediate price system like this, lambda times P prime plus 1 minus lambda times P double prime, which is not an equilibrium price system. Is it clear? By our second assumption, Z has non-empty values, there is at least a Z which belongs to large Z of this intermediate price system. Is it clear? This is by our second assumption. In this intermediate situation, which is not by assumption an equilibrium situation, however, there is a vector which is an excess demand vector, which is so to speak chosen. While note that vector Z, by definition of equilibrium, is an element both of Z of P prime and of Z of P double prime. There's nothing but the definition of equilibrium. Z0, the null vector, is an element both of these set and this set. Is it clear? But note that clearly in the intermediate price situation, obviously, this null vector is purchasable because the value of a null vector is absolutely equal to 0 for every price system. So this null vector is purchasable in this intermediate situation. But it's different from Z because we suppose that the intermediate price situation is not an equilibrium one. So we can apply our action, weak action of the Will preference. Since in this intermediate situation Z is chosen while 0 is purchasable but not chosen because the intermediate situation is not an equilibrium one, then in every situation in which 0 will be chosen, Z must be non-purchasable. But when the null vector is chosen, both in the first and in the second situation, so the value of Z prime, or Z, according to the first price system, must be a positive number. And also, according to the second price system, must be a positive number. This result is obtained by applying weak action or revealed preference. But if these two inequalities hold, also this inequality will hold, because you consider the intermediate price system, since both lambda and 1 minus lambda positive number, you obtain that at the intermediate price system, Z should be non-purchasable. But this is impossible, because Z was chosen in the intermediate price situation. In order to be chosen, Z must be purchasable. So there is a contradiction. And the set of equilibrium price systems is a convex set. Well, right, and then I shall repeat also this proof. The theorem tells us that if the existent correspondence Z verifies the weak action revealed preference at the aggregate level, and it has non-empty values, as a fundamental assumption, then the set of equilibrium price systems is a convex set. But I suppose that this is not true. Ab absurd, this is not true. Take two different equilibrium price systems, P prime, P double prime, and take any lambda, particular lambda 0, 1 in the interval 0, 1, such that this intermediate price system, lambda times P prime plus 1 minus lambda times P double prime, is not an equilibrium price system. If these were true, clearly our theorem would not be verified. By our second assumption, Z has non-empty values, however, there is at least one Z in this set, a Z which is chosen by the economy in this intermediate, according to this intermediate price system. Is it clear? While the null vector 0 is clearly an element both of Z of P prime and of Z of P double prime. Why? Simply because P prime and P double prime are equilibrium price systems. Moreover, clearly, vector Z is purchasable in the intermediate situation, because clearly a null vector has always a null value for every price system. But 0 is not an element of the set, and in particular is different from Z, because in intermediate situation, by assumption, there is no equilibrium. Now let us apply our weak action or revealed preference. In this intermediate situation, Z is chosen, while the null vector is purchasable but not chosen. So, in every situation in which the null vector is chosen, Z must be non-purchasable. But when the null vector is chosen, both in the first and the second situation. So, by evaluating Z both with P prime and P double prime, you obtain a positive number. Z is not purchasable in both of these situations. Now let us consider the value of Z according to the intermediate price system. Since lambda 1 minus lambda positive number, clearly this inequality must hold. But this is impossible, because in an intermediate situation, z is chosen. And so in order to be chosen, z must be purchased. And here we obtain the converse result. Impossible. And therefore our theory is proved. So by introducing this result, this assumption, sorry, warp, we obtain exactly the result, convexity of a set of equilibrium price systems. In reality, it's not necessary to suppose warp. You can weaken the weak action by a more general property, and another time you reobtain the same result. However, since this alternative assumption is relative to no regular preference, is a very complex one, I am limited myself to prove the most simple case, simplest case, the case in which warp, a very strong assumption about the entire excess demand correspondence, is verified. And this concludes this short analysis of uniqueness of equilibrium. After uniqueness, we should consider only the problem of stability of general equilibrium. In other terms, if you are not in equilibrium, there are forces which move the economy towards the equilibrium price system. The answer is, generally speaking, in the negative. However, if you assume another time the previous property, gross substitutability, it is possible to prove that not only equilibrium exists with all positive components, but it is a stable one. In other terms, when you adjust prices according to the usual variation Tatomma, increase the price of a good for which there is a positive excess of demand, decrease the price of a good for which there is a negative excess of demand, then the price system converges to the equilibrium one. But this result is very difficult, so we shall not see in this course. Now, let us have another break.